Hello everyone. Today we are going to simplify a core chemistry concept by starting with something we use every day, fractions. Before we look at complex chemical formulas, let us understand how we measure parts of a whole in our daily lives. Let us start with pizza. Imagine you have one full pizza that represents your whole. If you cut the pizza into four equal parts and you ate just one of them, you have consumed one out of the four parts. In maths and chemistry, we express this as fraction 1 by 4. That is, the whole four parts comes in the denominator and the part you consumed comes in the numerator. So which gives you a fraction. So this one comes as 1 by 4, which is 0.25. If you want to calculate the percentage of pizza you have eaten, what you have to do is you have to multiply this with 100. So that means 0.25 into 100 gives you 25 percentage. One thing you need to understand here, the fraction is the maximum number what you get is 1. So the number is very small, so that in chemistry, normally what we do, we will multiply that with 100 to make as percentage. That we will see where and all this fraction is converted into percentage. We will see in the later of this lecture. So in layman sentence, a fraction tells you how much of the whole you have. We can apply this to anything like a chocolate bar. If one whole bar is broken into 8 equal pieces and you have taken 3 of them, you now hold 3 by 8, 3 by 8 of the total chocolate. So the fraction of chocolate what we have is 3 by 8. So if you want to convert that percentage of chocolate you hold is just multiply this fraction with 100. Fractions are also the fairest way to share. If one cake is shared equally among 5 children, each child receives exactly 1 by 5 of that cake. This reinforces the idea that when something is shared equally, every individual share is represented as a fraction of the original whole. So here also you see the fraction comes as one child has 0.2 fraction of the cake the child has. So if you want to convert that into percentage, you have to multiply that with 100 so that you will get 20 percentage of the cake each child gets. So now let's bring this closer to chemistry using a glass of water. A full glass represents one, that means one fraction, while half glass represents is 1 by 2, that means one part in total of two part. The quarter glass represents 1 by 4, that means one part divided by 4 parts. You may ask like why we have to take 4 parts? We can take 8 parts also. Then that time what will happen? So you have 8 total part, we have total 8, therefore 8 by 8 also again you get the fraction 1. If you take like half glass 1 by 2, so the total 8 parts, in that one part is what? Now it is 2 part. So 2 by 8, again it become 1 by 4. So a fraction is visual and mathematical way to show how full or empty a container is, or how much of the specific substance is present in the mixture. To summarize our progress so far, a fraction simply means a part of whole. It is a way to tell someone how much of the specific item we have when compared to the total amount present. So, How does this relate to your chemistry textbook? Just like a pizza fraction tells you how much pizza you have, a mole fraction tells you how much of one specific substance is present in total solution. For example, if you have a solution with total of 10 moles, it may be A, B, C, three different molecules, but the total mole is 10. Now we have substance A, which is 2 moles. Now, how much fraction of A present? Now it is very easy for you, right? So, to find out fraction of A present, how much A divided by total moles. So, 2 by 10 gives you zero point 0.2. So the mole fraction of A is zero point 0.2. So now, if you want to convert this as percentage, because zero point 0.2 is very small number. So to make is as a big recognizable number, just multiply with 100. It will give you a fraction more in percentage. So it is 20%. Always remember, fractions answers one simple question: out of total, how much is this? Finally, we use this fractional concept to calculate various type of concentration. So now you see, now in this slide, we have given mass percentage, weight by weight, volume percentage, volume by volume, parts per million, mole fraction. So all these formulas, don't try to memorize it. Yeah, all the formulas derived from one simple concept we have discussed until now. That concept is fraction. Here you see mass percentage of component. If you remove, multiply by 100, it is mass fraction. If you remove into 100 in volume percentage, it is volume fraction. If you remove the parts per million, that is into 10 to the power of 6, it becomes fraction of parts. If you remove in mole fraction, it is mole fraction only. If you multiply this with 100, it will gives you the percentage of mole present in the total component. So what the mass percentage of component gives, mass of the component in the solution, that particular component which is of our interest, divided by total mass of the solution. This gives you a fraction of the component in that solution. If you multiply by 100, it will give you the mass percentage. Similarly, the volume of our component divided by total volume of the solution gives you fraction of the component, volume of the component. If you multiply that with 100, it will give you the volume percentage of the component. Similarly, number of parts of the component divided by total number of parts of the all component of the solution gives you fraction of parts of the component. So here, instead of 100, why we multiply here with 10 to the power of 6? That is very interesting, because where we use the parts per million, where we have very small number. Let's say, for example, the parts per million always comes like 5 parts per million, 10 parts per million. Okay, so if you don't multiply this with 10 to the power of 6, the number will be very small. It will be like, let's say, for example, your particular calculation gives you 5 parts per million. So if you don't multiply with this with into 10 to the power of 6, then how we have to tell means 0.000005. So it will be very difficult for you to remember and write and tell. So that is the reason you are multiplying with million. 10 to the power of 6 means 10 lakhs. 10 lakhs means 1 million. So you're multiplying with 10 lakhs because that number is so small. So here you are multiplying with 100 because you get less than 1, not 0.0005. So why we are multiplying with 100 make as percentage? Why we are multiplying with 10 to the power of 6 to make into parts per million? Just to have that simple, easy to remember number. So that is the whole purpose, to make as parts per billion. So finally, we will discuss about mole fraction. Mole fraction is number of moles of the particular compound divided by total number of moles of the compound. So in the previous slide, we have discussed this concept. Thank you very much.